discuss these things. So these are the okay. So the basic part of transmission and distribution is the first module, which we see as the concept, the introduction to power system. Then is the overhead transmission line. Module 2 consists of line parameters, that is the transmission line parameters. Then comes the module 3, which is about the performance of transmission lines. Then module 4, it is corona, not the current pandemic that we are going through, but corona is a phenomenon in power system that you will come to know. So module 4 is about the corona, and module 5 is the distribution systems, because the subject is about transmission and distribution. Now, what is transmission, what is distribution, that I'll discuss first as an introductory class. So you see, for the first people who do not know, or people who are unaware of this electrical power system, that is the electrical system, consists of three parts: the generation, the transmission, and the distribution. Now this electrical system that we see in our everyday's life, also the consumer, we are the consumer who get the load side, we consume the electricity to run everything. Now this electricity that we are getting in household or the industries or commercial purposes everywhere, so it is delivered to us. How it is coming to us and how the entire system is working, this is all about the power system, electrical power system. Now the electricity that is coming, we are consuming it, everything is fine, but how the entire process takes place, that is where it is divided into the three parts. First part, as I told, is the generation part. I think you all have gone through generators. The subject generators was there, TNG. Okay, so that subject you have studied the transformers and the generators. So basically, what is the function of transformers? Transformers, they step up or step down from one voltage or current level to another voltage or current level. So that is the function of transformers. And generators, what do? They generate the electricity, they generate the electric current. Okay, so it is mechanical to electrical energy that is being converted by the generators. Now, these are all components of the electrical power system: the generator, transformers. These are the very important parts, or basically the core parts that form the entire power system. Okay, so before moving, I'll just let you see that how electrical power systems introduction. Okay, so an electrical power system is a network of electrical components deployed to supply, that is, they are given to supply, transfer, and use electric power. This network of power system comprise of the generation, transmission, and distribution. Do not confuse transmission with transformer. Yes, it has an important role. Transformer is an equipment, generator is an equipment, and generation is the phenomenon. Transmission is the phenomenon, distribution is another phenomenon. Okay, so these are the things that happen from the certain equipments. Okay, now electric power system is usually understood as a very large network that links the power plants, both large and small, to the loads by means of an electric grid. Am I audible to you all?
Yes, ma'am.
Yes, ma'am.
Okay. So this power system is just the introduction to the power system that is getting. Now each of these components, generation, transmission, and distribution, we will be studying in detail. And this is where our subject is about the transmission and distribution part. And the generation part is another subject, which is power generation and economics, 18 EE 42. Okay. So that is 18EE 42, and our subject is transmission and distribution part, that is 18EE 43. Now, moving to the introduction of this part, these two, generation, transmission, and distribution. You see, there is a lot of things written. I'll tell you in short what basically they are. Generation part is where one energy is converted to electrical energy. Okay, so what converts them? We have some sort of raw materials, be it coal, be it water, be it anything, any raw material or the fuel rather, that helps us to gain the electrical energy out of other form of energy. Now that conversion is done by generators, alternators, or any other equipments. They give rise to the electrical current. Okay, and the basic law we all know, that is electromagnetic induction is the basic law of all machines. Okay, be it transformer, be it generator, yes. The machines part, they are rotating, and transformer is static piece of apparatus. So this much we know. So the generators convert the electrical energy, and that electrical energy, now what happens, we are consuming it to this consumer terminal at the household voltage. We all know, I think, the household voltage and the frequency what it is. It is 230 volts, single phase, 50 hertz, right? Now this is the voltage level of our consumer side. But when the generation happens, it happens not in such a low voltage. Generation takes place at a certain voltage level, voltage frequency. There is a certain voltage and frequency during the generation part. Okay. Following the generation, and we are towards the customer terminal, so we are getting it after the distribution, means after the three stages are over. Okay, so this three stages means the generation, transmission, distribution. Then we are getting our terminals. So between generation and our terminal, there are these two things named the transmission and the distribution. So what happens in transmission and what happens in distribution? When a certain, at certain voltage and frequency, the electricity is generated, and we need at a different voltage and frequency level for the consumers. So what needs to be done? The generators part are located far away. Okay, far away they are located, and we, the customers, are located in very remote places or other places very far away from the generation part, where the generation is happening. From there, we, the customers, are located very far away distances. So how is it possible? What are the things that needs to be done? So there lies the function of transmission and distribution. Transmission means what? To transmit. To transmit that generated power to our terminals. So when that generated power is happening in any power plant, suppose in any power plant it is taking place, from there long distance transmission lines are there that transmit that electric power. Now how do they transmit, and why is such a long distance necessary? You see, I'm just reading this part. Power from the generation plants is carried first through the transmission systems, which consists of transmission lines that carry the electric power at various voltage levels. A transmission system corresponds to a networked meshed topology infrastructure connecting generation and substations together into a grid. The electricity flows over high voltage transmission lines to a series of substations where the voltage is stepped down by transformers to levels appropriate for distribution system. So what we need to understand, that during the transmission, the power generation plants, from them it is carried by the high voltage overhead transmission lines, so that that power which is generated is transmitted at a very high voltage and at a convenient voltage and frequency. Now this is a very important point. Why do we need to carry the transmission at such a high voltage? This is a very important question also, as a very important point also to understand, that What is the necessity that we have to carry at high voltage? Means the generators are generating at a certain voltage and frequency. From there, we have to step up using transformer, obviously, step up the voltage, and by stepping up the voltage, that has to be carried to long distance at that high voltage, and then again stepped down, and then for distribution it will be distributed. So that high voltage the transmission occurs. This is first thing. And second is that before going to the distribution, it is the work of the transformer only to step it down. Next is the distribution. So the component of the electrical power system connecting all the consumers in an area to the bulk power sources is called a distribution system. The bulk power stations are connected to the generating substations by transmission lines. They feed some substations which are usually situated at convenient points near the load centers. Now, as I said, we are the consumers. We are the load centers. From the load centers, we are consuming it. Okay. So from the load centers, as we are consuming it, we have to get that voltage and frequency, which is the stepped down voltage from the transmission. Means from the transmission, it is stepped down. Then it is again subcomponent wise stepped down. Means there are many loads that are tapped from the distribution feeders, so they get trapped down, and that power, that electric current is supplied to the consumers by the load centers. So that part is the distribution part. Now there is something very important regarding this transmission, generation, transmission and distribution part. I'll just follow it up. Now I'll just say that very important components of this transmission and distribution are the service mains, the distribution feeders, or rather the feeders, and the substations. So these things are very important. I'll function wise, they can say that explain the feeders, distributors, and service mains. What are they? So that we will go on to eventually. Now, before going on to that, I'll just give you a brief outline of how this entire thing takes place. Means the single line diagram. Okay, I'll show the single line diagram, which is a one line diagram of power transmission and distribution system. Let's just see that like a flow chart. So this is how it looks. Okay, the first point, the circle that is being shown, that is the generating station. So this is where the generators are there and they are helping in generating the electrical power. So generation happens to be there in the generating station at what voltage? 11 kV to 25 kV. Just very important, the voltages are, note the voltages. Voltages are the most important thing in power system. Okay. So for the voltages, the generating station, it generates as like 11 kV to 25 kV. From them, from the generator part, it is going to the transformer, which is the step up transformer. Stepping up to what voltage? 11 kV to 220 kV. Okay, 11 kV to 220 kV, as you can see. I hope everyone can see the diagram.
Yes, ma'am.
Okay. So the first circle, as you can see, that is the generating station. Then there is the step up transformer. So this is where the starting of transmission is beginning. Means it comes and you are just applying the transformer. From there, the transmission part begins, where next, that after stepping up with the help of transformer, it is going to transmission lines. Okay, so transmission lines are carrying that electric current, the power, electric power, to 220 kV to 400 kV. The line strengths or the voltage levels are 220 kV to 400 kV. Now these days there are more the line voltages, higher capacity, high ratings are there. But this, as far as our bookish knowledge is concerned, they say that 220 kV to 400 kV. Okay, so now for after that, after the transmission lines are carrying, it is then stepped down. Okay, so when it is stepped down, with the help of step down transformer, its voltage rating becomes 220 kV to 33 kV. So this is the step down transformer. So step down transformer steps it to 33 kV. Then from that, after stepping down, there lies the sub transmission voltages. So the sub transmission voltages is from the rating of 33 kV to 138 kV. So 33 kV to 138 kV, it is the large consumers they will take from here only. Means from the sub transmission level only, large consumers will consume directly from here. Then after the sub transmission voltages, then again the transformer happens to be there, which steps down again. So that there lies the step down transformer again, which is 33 kV to 11 kV. So we are again getting back to 11 kV. Now from 11 kV starts the primary and secondary distribution levels. So primary and secondary distribution levels are from where it will go to the consumers. Now the medium consumers, they take it directly from the primary distribution level, and the secondary distribution level the small consumers take. Okay, so the rating of that is, for the small consumers we can say that 400 to 230 volt, that is the rating. So we see it is actually from 11 kV it is turning to 400 kV, 400 volt, 400 volt for the medium consumer, and from the 11 kV from the small consumers it is going to 230 volt. Okay, so small and medium division occurs in the distribution level. So this is the single line diagram of the power transmission and distribution system. Very important. Okay, so these are something that is important for the finals also, means for the exams also, because this is a very standard question and the first question that happens to be there occurring in your exam paper. That is, draw the single line diagram and mention the standard voltages. So these are the standard operating voltages of transmission and distribution. Just note that from which voltage level to which voltage level the transformers are stepping up or stepping down. Okay, so before transmission lines it is stepped up, and after transmission lines it is stepped down. So there lies the function of stepping up and stepping down. Transformers are the primary component of this. Just because of this voltage level stepping up and stepping down, obviously it happens with the help of transformers. So transformers are the most important part, the most important part that helps in doing the proper functioning of this entire single line diagram. Okay, so for the generation, just note the voltage levels. For generation, 6.6 kV, 11 kV, 22 kV and 33 kV can be used. Okay, primary transmission, the voltage levels are, these are standard operating voltages. Okay, standard or practical operating voltages for TND, transmission and distribution. So the after generation, which is happening at 6.6, 11, 22 and 33, there is primary transmission. Primary transmission level voltages are 66 kV, 110 kV, 132 kV, 220 kV up to 400 kV. I am not mentioning that it is actually beyond the books. If you see, then it is actually 750 kV, or rather 1200 kV we have reached for transmission. Okay, so these days high voltage transmission has reached to an extreme level. So that happens to be at almost 1000 kV or above 1000 kV. Okay. So, but normally it is 400 kV only. Means if it is not that much advanced the power system is, then it is 400 kV only. Okay. So up to 400 kV, the primary transmission occurs. Now, for secondary transmission, what is the level where it is stepped down? 11 kV, 22 kV, or 33 kV. Okay, so that is the level for the secondary transmission. Next is the primary distribution and secondary distribution. So for the primary distribution, 3.3 kV, 6.6 kV, 11 kV is used, and that is used for what? For the distribution of large consumers. For the distribution of large consumers, primary distribution occurs. Okay, 3.3, 6.6, 11, these are the ratings of the voltage levels. So for secondary distribution, 230 volt and 400 volt for low voltage distribution happens to occur. So this is very important. Anyone has any questions, please ask. Any questions, anyone, regarding this one line diagram and the voltage levels and what is happening? Anyone who is not getting, not understanding the entire process, please raise questions. If you have any, then raise questions. I hope
Ma'am,
this is understandable to all then. Huh? Anyone question?
yes, ma'am. On what basis we classify large consumers, medium consumers, and small consumers?
Yes, large consumers are basically the industrial requirements that need high voltages. Okay, so this classification that you are asking, that on what basis we classify, it is actually the voltage levels on which we classify. Means suppose very high voltage levels are needed for an industry. Okay, so even high voltage industry is one of the industries. They require a very high voltage levels. In fact, they require three phase also. So when they require the three phase, they directly go from the sub transmission voltage, that part only. That step it is written sub transmission. So for that, which is carrying on in three phase. So from there to large consumers, it is going because the industry requirements, some of the industry requirements, they require very high voltages and they are considered as large consumers. Okay, so it is the voltage levels and the capacity or the functioning of that part. That is what we classify as large consumers or medium consumers or anything. So it is basically the voltage level. Okay. Anyone,
Yes,
any
ma'am.
other? Just understand the flow chart. This is consider this as a flow chart. Okay. Where the first step is generation and the last step is the distribution to the small consumers. So between generation and the distribution lies the transmission. Now transmission has two parts, the primary transmission or transmission lines and the sub transmission. So the transmission lines, I think you all have seen when you travel to large distances via railways, you will see railways or even the buses transportation. When you see for the highways, large distances, you will see transmission lines for sure. The towers, they carry the transmission lines. Towers acts as the supports and the transmission lines goes in three phase. They run in three phase and over very vast distances there are many such towers carrying many such high voltage lines or the conductors that is being carried. Especially if you travel in railways, you will see off the fields where the farming takes place, where the agricultural crops are grown. In between them, they run the transmission lines. They are crossing far off fields and very large distances to the remote places, even the transmission lines carry. Okay, so transmission lines are those only which are being carried, the conductors in is being carried between the tower. Okay, so I'll move to the next part, that why are we actually increasing the voltage in the transmission part? Means the generation is happening in 11 kV to 25 kV or 33 kV, whatever. So from that kV, why is it stepped up to such a high voltage of up to about 400 kV? Here the diagram shows 220 kV, but the maximum limit as it is written in there, it is 400 kV, right? The primary transmission. So why is it needed that it is generated at this 25 kV, 33 kV, and then it is increased to such a heavy level of 400 kV? What is the necessity of such a high voltage? That we will be doing. Now you see, I'll just discuss this in brief, that why is it necessary. What happens, these are the advantages only, but the advantages carry the significances which is not here. Here I have just written the points. I'll just tell the points first. Advantage of high voltage transmission, why is it carried at such a high voltage? First is that reduction in current. Now I have only written here reduction in current. How? Just just think that electrical power, a constant power is being supplied by the lines, electrical lines. It is carried from the sending end to the receiving end. Just imagine, okay, there is a sending end, there is a receiving end, and in between them the transmission lines are being carried. So the power, I think you all know, it is vi cos phi is the active power. I hope by now you know. Yes or no?
Yes, ma'am.
Yes. So Vi cos phi we can consider as the power. Now, if that power is constant, okay, and if high voltage transmission takes place for that constant power, obviously current will have to reduce according to formula. Are you getting my point? I am telling that P equals to Vi cos phi. Okay, P is constant. Okay, V voltage P equals to Vi cos phi. P is constant. V is very high. So I should be very low to get P constant. I think it is not clear. Anyone not getting? Please. Okay. Better I'll explain. I'll just stop presenting. I'll just explain. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, I am sharing a different thing, a different PDF. I hope this will be clearing the confusions. As I said you that the first point of high voltage was that at high voltage current reduces. Now why that current reduces? Considering obviously that the transmission line carries constant power. It is assuming, okay? So for constant power, if voltage increases, obviously current will decrease. To explain this, I'll go formula wise. So I'll be presenting. Okay. Everyone just say that whether it is visible or not. Is it visible?
Yes, ma'am.
So power P is equals to root 3 VI cos phi. This is for the three phase, obviously. Okay. So for the three phase, P equals to root 3 VI cos phi. That means I is equals to, just interchange the place with I. Okay. I is equals to P divided by root 3 V divided by cos phi, which is this. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. So, for constant power, if the voltage increases, the current will definitely decrease, because I is basically equals to P divided by root 3 V cos phi. I'm just telling you, just see that reduction in current that takes place because it can be seen that for constant power and power factor, the load current is inversely proportional to the transmission voltage, right? From the formula itself, it is clear that the current is inversely proportional to voltage. Yes or no? Current is inversely proportional to the voltage. We can say or no?
Yes, ma'am.
So obviously, if current is inversely proportional to voltage for this formula, then if voltage increases, current will decrease. If voltage decreases, current will increase. Just the reverse, the vice versa. So that is why if we carry it at a very high voltage, means the transmission takes place at very high voltage, then the current will decrease. And why do we need to decrease the current? There is also a function for that. We need to decrease the current because losses are I square R losses. So the losses will be very high if the current is high. So reducing the current means the losses will also decrease. So the first point was reduction in current. And the next point now here is the reduction of losses. Everyone is able to see?
Yes, ma'am.
Yes, ma'am. Okay. So
Yes,
reduction
ma'am.
in losses, yes, yes. Reduction in losses is given by W, which is watt, rather to be specified, watt. Watt is here for three phase, 3 into I square R. So I is previously found as P divided by root 3 V cos phi, right? So just putting that value of I into I square R, that is the loss part, power loss in a transmission line. Now that is given as W equals to whatever we are getting, P square R divided by V square cos square phi. From here we can say that power power is inversely proportional to the square of the transmission voltage. Okay, so the greater the transmission voltage, lesser is the loss. Yes or no? Greater the transmission voltage, less is the loss. So it is inversely proportional to the voltage. Power and voltage is also inversely proportional. Yes or no?
Yes, ma'am.
Yes,
Okay. So till this part, everyone clear why we are going to high voltage?
yes,
Yes, ma'am.
O- Okay. So the first point was reduction in current. The second point is reduction in losses. Okay. The third point is reduction in the volume of conductor material. For the conductor material, the reduction happens because less conductor material will be required at high voltage. Now why, there is also a proof of that. I'll share this with you. So today I'll just move on to completion of the slide first. It is visible?
Yes, ma'am.
yes,
Yes, ma'am.
ma'am.
Okay. Okay, like whatever I said, that there is respective deduction for each of the points. Reduction in current I showed you, reduction in losses also we showed you. Now reduction in conductor material also, there is a small deduction, very small and very easy one also. So we will go point by point regarding this. This question is very important. What are the advantages of high voltage transmission, and why we are writing these points? So because there is a deduction for each one of them. Okay. So reduction in current, reduction in losses, then conductor material is also reduced. The volume of the conductor material reduces. So that is again a plus point. That is again an advantage for high voltage transmission. Next is that the voltage drop in the line that decreases. So voltage drop means what? Maximum voltage, it is eating up the voltage. The line is eating up the voltage. So that also decreases. The voltage drop decreases. Okay. Next is the improvement of voltage regulation. Then there is increased power handling capacity. Power handling capacity increases in high voltage. If you do it in low voltage or medium voltage, whatever the power handling capacity will be, for high voltage, the power handling capacity will be obviously very high. Okay. Next is the increase in the transmission efficiency. This is also a very important deduction is there. We'll do that. Next is the total line cost per megawatt per kilometer that decreases with increasing line voltage. Next is the number of the circuits and the land requirement also reduces. Then there is operation with high AC voltage that is simple and reliable. So these are the advantages of high voltage transmission. Now, obviously, with advantages comes some of the disadvantages. Not obviously, advantages are more for high voltage rather than disadvantages. So these are the high voltage transmission advantages, and this is the disadvantages. What are the disadvantages? Corona loss and interference, line supports, erection. We'll discuss it later, point by point. I think the class time is already over. Your next teacher will be waiting for you. So for today, I'll just skip it. Thank you. You can leave for today's class. I've already taken the attendance, so thank you. You can leave.
Okay.